Welcome back. We're in Giancoli Chapter 2, the acceleration questions and problems, set to problem number 1. In coming to a stop, a car leaves skid marks 80 meters along on the highway. Assuming a deceleration, an acceleration, but they're slowing down here is what they meant, of 7 meters per second squared. Estimate the speed of the car just before braking. Cool. Well, first we're going to give a picture here of what's going on. So I'll do my best at drawing a car, and you should do as well. That's not so bad. And somebody's driving that thing. And they got really long legs there. Okay, cool. The point is that you can see which way it's going. Here's some headlights there, and so whoosh, you can kind of see the motion there almost. So it's got velocity going that way, and then it's got acceleration pointing that direction there. Okay, cool. We'll give them a road to go on, and we'll say that that road is not moving. It's an immovable surface there, which is what these lines are implying here. And that's it. Okay, cool. There's the picture. Let's put the skid marks on there, though. Leave skid marks 80. Well, I guess the skid marks would be over here. Now I planned this whole terribly here. Here are the skid marks there. Well, just before braking. Well, I guess I don't want to put that over there because now it's not moving anymore. So I guess we'll kind of do a time lapse. We'll do like a movie like time lapse thing. This is just before he braked, and then here's his skid marks here that are 80 meters long after he's going to brake. This is what's happening in the future, I guess. Oh, Back to the Future. And then the acceleration here we know is going to be 7.00 meters per second squared. Now it's pointing to the left there, and we'll assume that to the right is positive and to the left is negative, and so that's going to be a negative acceleration there. We have an initial velocity of big old question mark. We don't know what that is. The ending bit, well, he's braking, he's coming to a stop, and so the ending bit is going to be 0. And this 80 meters, we could label that as like a displacement there of 80 meters. Need to be a little bit more neat by that. All right. So listen out some knowns and unknowns. It's always a good thing to do. And so now I could do this in a bunch of different ways. I could do this graphically or algebraically. I'm going to choose to do algebraically because I see that I have delta x and a here. So I know that my change in displacement is going to be 1/2 acceleration times time squared plus v naught t. And so what am I trying to find? Well, I'm trying to find, let's see if this equation will work. So let me run through it. Delta x, I got that one. Acceleration, I know that too. The time, I don't know the time. Okay. And then v naught, well, I don't know v naught either. Okay, well, we had 2 unknowns here. So I have like 2 question marks here. So I can't use that equation all on its own. Let's go look at another equation. We got v is equal to at plus v naught. And if I look at this, I go, I know the ending velocity, I don't know the beginning, I don't know the time, but I know the acceleration. Well, now I have 2 equations and the 2 unknowns between them. I don't know the time between them, and I don't know the original velocity. Math says that I can combine these things and figure out what the answer is. So we can do it that way. We can do another way. We got v squared is equal to v naught squared plus 2a delta x. Now this, if I use algebra, I combine these 2 equations right here, and I eliminate time, I get this equation right here. You should try that on your own because it's good algebraic practice and exercise. It's not too hard, but it's very easy to make a mistake along the way. So if you combine these 2 and just knowing that you're going to go solve for v squared, it's not so bad. Try it out. It will do you well. Okay, so we could maybe use this. Let's try it out. V squared, v we do know. V naught we don't know. A we know, and delta x we know. Okay, cool. So I could use this one straight away, and that's why using algebra to combine these is very useful. So let's go try that, and then maybe at the end I'll go do the other one. So my v is 0 squared plus, I don't know what this is, plus 2 times negative 7.00, and I'm going to leave out the units until the very end there, and 80 meters. So now I can move that bit to the other side there, and so I have a negative, so that's going to become positive there. So 2 times 7 times 80 is equal to V naught squared. And now I just go and grab my calculator. 2 times 80, that's 160. 160 times, oh gosh, my calculator just ran out of battery, so let me pause this. All right, and you get 1120. And that's V naught squared, so I go and take the square root of that, and we get 33.47 meters per second. Shunk. So that's how fast he's going in meters per second. The real rough estimate is if you double that, that's about miles an hour, so that's about 66 miles an hour there, 67 miles an hour. Little bit different than that, so you can go look that up though. But that's it. All right, have a wonderful day. See ya. Bye.